All right, so let's talk real quick about how Mr. Rick Millen forgot to put in example 6 into the notes. So here is the additional video for it. And so looking at summations, which is the sigma notation, and the sigma is just this Greek letter here, it's the Greek letter sigma, and it just stands for the sum of what follows. And so let me talk real quick about how that sigma notation works, and I'll just give you like a little quick, easy example before we get into this geometric sequence. So let's say I have the sum from n equals 3 to 5. So this n equals 3 is your starting point. The top number is where you finish, what n value you're going to use. And let's say that I just have 2 in here, right? And so what this means is I'm going to take every integer value between 3 and 5 and plug it in for the n. And then I'm going to add all those items together. So I'm going to get 2 times the 3 plus 2 times the 4 plus 2 times the 5. And so I get 6 plus 8 plus 10, which is 24. So the sum from 3 to 5 of 2n is equal to 24. Okay. Now, when we deal with geometric sequences, we're still going to deal with our formula that we dealt with in the previous problems. A sub 1 minus a sub 1 to the r times r to the n over 1 minus r. And so we're still going to find our information from this. But understand that if our n, or our k value, you'll see both variables used there, is not 1, it doesn't represent this a sub 1. It represents the first term of this summation. Because in this problem, we're not looking for the first term to the 10th term, we're looking for the second term to the 10th term. And so I don't have 10 terms here, I only have 9. Because if we think about listing out a sub 2, a sub 3, a sub 4, and working our way out, a sub 5, a sub 6, a sub 7, a sub 8, a sub 9, and a sub 10, how many terms do we have? There are 9. And so the easiest way to find this is you take the two numbers, so the 10 and the 2, so you go 10 minus 2, and you always add 1 back. And so that will give us the 9. This will be your n for this problem when we go to plug it in to our series formula. Okay, so with that being said, what is our a sub 2? Well, a sub 2 would be the 3 times the 2, and 2 minus 1 is 1. So a sub 2 is equal to 6. So that becomes my a sub 1 that is going to plug in here and here. And so let's do that now. And so I'm going to get s of n is equal to 6 minus 6 times the r, this is still your r, 2 times n, this n, right, 9, over 1 minus your r, which again your r is still 2. So s of n is equal to 6 minus 6 times 512, because 2 to the 9th is 512, 2 to the 10th is 1024. And some of you still play that 2048 game, which is 2 to the 11th. 1 minus 2 is negative 1. So s of n is equal to 6 minus 3072 over the negative 1. 6 minus this is going to give us a negative 3066. Divided by the negative 1 means that this will be equal to 3066. So what that means is that if I take all the terms, a sub 2, a sub 3, a sub 4, all the way to a sub 10, and I were to figure out what those terms would be, so this one we know is 6. And if I take the next term, it'd be 2 squared, which is 4, times the 3, so it'd be 12, right? And I go all the way out, and I find all the way out to a sub 10. And then I add all those values together, it'll equal 3066. That's how that problem works. Again, sorry I didn't get that in the video yesterday. That was a mistake on my part and just skipping it when I was writing these notes out. So there you go. Hope this helps, and hope, again, y'all have a great day.